Right, good evening. This is VK3 EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria with a regular Friday night broadcast, coming to you from the studios of VK3 CSJ in Narre Warren South. This is VK3 EKH broadcasting on prime frequency of 3541 kHz in the 80 metre amateur radio band and simulcasting on 160 metres on 1865 kHz. We're also broadcasting via the Melbourne TV digital repeater VK3 RTV digital channel 2 in glorious HD, and also streaming via the YouTube channel, which can be found on the ASV website at www.asv.org.au. That's www.asv.org.au. Under the Radio Astronomy tab, look for the ASV broadcast, and you should be able to see the YouTube feed from there. On the same website you'll see the link to the Discord chat window, and I can see there's already a few chaps up there on the Discord chat window. Very pleasant good evening to Martin, VK7JAH down in Tasmania, and I thought Rob was from last week. Anyway, we also have a email address, vk3ekh at gmail.com, vk3ekh at gmail.com. Pleasant good evening to everybody, and trust everybody is feeling well this time of the year, rapidly coming up to the Christmas holiday break, and we'll also take a few weeks off. I'll make the last broadcast in a couple of weeks' time for a few weeks. Anyway, we have a few articles tonight, but we also have the part 2 interview with John Sarkisian, operational scientist from the Parkes Radio Telescope, and I've got that queued up ready to go. And also we have the latest from our solar space woman, Tamitha Skov, and the latest events with our sun and what's happening with things up there in space weather. So we'll queue her up in a little while too. Meanwhile, we'll because it's the 3rd of December, we have the sky notes from the Planetarium available. They've come through. So for December, let's see, they've got a few things happening at the Planetarium. So I would suggest that the events that are occurring at the Planetarium be just a good idea just to simply visit the ScienceWorks website and look under the Planetarium, and you'll see things like Dome Under Festival, Best of Earth, Astro Hour for Families, The Light Fantastic, Astro Hour for Adults, The Light Fantastic, and Planetarium Nights. So there's a lot happening at ScienceWorks, particularly in the evening hours it seems, for going to the Planetarium. And it sounds like a really great thing. I've yet to go there and see the some of the things that they do. Anyway, alright, so Melbourne sunrise times. We usually kick off Sky Notes with the Melbourne sun times, sunset and sunrise times. What we have here is that for the 1st of December, sunrise was at 5:51 p.m, setting at 8:26, with 14.34 hours of daylight. Then on the 11th of December, which is next Saturday, the Barbecue Day for the Astronomical Society of Victoria up at Heathcote, sunrise will be at 5:51 and sunset will be at 8:34, with a total hour day of 14.33 hours. Then on the 21st of Tuesday, sunrise will be at 5:54, setting at 8:41, 14 hours 47, And by the end of the month, on Friday the 31st of December, sunrise will be right on 6 o'clock, setting at 8:45, with the total daylight hours being 14 hours and 44 minutes. Now they say something about a partial solar eclipse. Last month we had a partial lunar eclipse, and this month on Saturday, December the 4th, tomorrow, there will be a solar eclipse with the moon obscuring part of the sun. Don't think that's going to happen so much in Melbourne, but what they say here is that in Chile and Argentina it will be a total eclipse, with the entire solar disk covered for a little over 2 minutes. Yes, 2 months. Yes, no, 2 minutes. I was about to say 2 months. It just felt like 2 months, but just a little over 2 minutes. In Melbourne, however, it will be a partial solar eclipse with only about 1% of the sun disk obscured. So I would still strongly suggest not to go looking at the sun without proper protection on your eyes. Anyway, unfortunately, it will not be grandly impressive, and the sun will be very low in the sky nevertheless. The moon will briefly graze the edge of the sun. The eclipse will occur in the evening just prior to setting of the sun, and the end just after sunset. A clear view to the southwestern horizon will be needed. The Earth, Moon, Sun lineup for the solar eclipse means that the moon will not be visible because the side facing the Earth will not be lit by the sun or by sunlight. If viewed safely, it will appear as if a small corner of the sun is being eaten for a short time. So that's tomorrow. Yeah. So there is a time schedule here. The eclipse begins at 7:53 p.m. Maximum 1% eclipse will be at 8:12 p.m. with sunset occurring at 8:29 p.m. Eclipse ends below the horizon at 8:30 p.m. Total duration 36 minutes. So if you've got a very good view of the western horizon, if you're down at the bay, for instance, Port Phillip Bay, and looking across to the west, and if there's no clouds, you've got a chance of seeing this partial 1% eclipsed sun, for what it's worth. So, but as the Skynote's site says here, never view a solar eclipse directly. Do not use sunglasses, X-ray or camera film, smoked glass, or most dangerous of all, binoculars or telescopes unless fitted with a special solar filter. Blindness or permanent eye damage can result. The safest way is indirectly by projecting the sun's image onto a surface. A pinhole in a card will allow the sun's image to appear on a second card or smooth surface. So yes, there you go. Over the next 20 years there will be 15 total solar eclipses around the world. The next for Australia will occur on the 22nd of July 2028, when the moon's darkest shadow, or umbra, will race across the continent from north of Broome, past Dubbo, and then directly over Sydney. It will continue across the Tasman to the South Island of New Zealand, close to Queenstown and over Dunedin. So that'll be worth waiting for. 22nd of July 2028 will be the next total solar eclipse here in Australia. Might just make it worth the trip up to Sydney just for that. 28, I'll be 68. Moon phases. There's a new moon on the 4th of December, tomorrow. There will be a first quarter phase on the 11th. And then on the 19th of December there's a full moon and a lunar eclipse. And on the Monday the 27th is the third quarter. The moon will be at perigee, closest to Earth, on Saturday the 4th at 356,794 kilometres, and it will be at apogee or furthest from the Earth on Saturday the 18th at 406,320 kilometres. Let's see what else they've got here. What are they talking about? Just probably a little bit of information on the reason why we have the moon closer and further away. They've got a couple of paragraphs here. The moon's perigees and apogees result from the shape of its orbit, which is not circular but elliptical. But the moon's path is certainly not static or fixed. It changes over time. The average Earth-Moon distance is 384,400 kilometres, and yet the difference between its extremes is about 42,000 kilometres, and no orbit is exactly the same. The Moon and lunar distances are affected by a number of factors, including the gravity of Earth and Sun, the tidal effect with our oceans, or from our oceans, local mass concentrations in the crusts of Earth and Moon, and both bodies even wobble slightly on their rotational axis over a long time scale. Add the fact that its orbital speed changes faster when closer to Earth and slower when further away, and you realise that old Luna is a forever changing partner as it dances with the Earth around the Sun. The Moon's perigee this month will be closest to our neighbour and has been all year. During 2021 it has varied from 229,980 kilometres in February to this month's closest of the year. Perigees this year have ranged by 8,278 kilometres. Equally, the Moon's monthly apogee has changed too. It was furthest in May, and over the year that monthly distance has varied by 2,412 kilometres. So there's a few little interesting things there. And I was, excuse me, I always like to indicate that the Moon's its orbit's tidally locked with the Earth, so that's the reason why we only see one side of the Moon. But the Moon does rotate. It does one revolution every month, so effectively the Moon is rotating, even though we see one side of the Moon. Really interesting to know that. When I first found that, I thought, oh, that's interesting. Okay, let's see what else I've got here before we lose too many more minutes. There's lots of interesting things here they've got. Summer solstice, okay. It will be summer solstice in the southern hemisphere on Wednesday the 22nd December. For Melbourne, that will be at 2:59 p.m. On that special day of the year, the sun will rise at its most southerly point in the eastern horizon, reaching its highest elevation of the year, and set at its most southerly point in the west. With Earth's tilted axis at 23.5 degrees with respect to the plane of its orbit, the southern hemisphere will be leaning towards the sun. Sunlight will be almost perpendicular reaching the ground, and the sun's path across the sky will be the longest, and daylight hours will therefore be the greatest. All these factors lead to our summer warmth. This is in direct contrast to winter, when the opposite conditions apply. The south leans away from the sun, rays are at a shallow angle, and the sun's path is low and short, and the daylight hours are the least. So that's the 22nd of December, Wednesday. I think we finish up work that day. Planets. Okay, quick rundown of the planets. What's happening with the planets? G'day to Don, Andrew and David, who's called in on the email list there. This is VK3 Echo Kilo Hotel, VK3 EKH, with the regular Friday night broadcast. Mercury is not visible this month, being too close to the Sun. Venus has been the evening star in the west during the last few months and will continue to be visible into December from 9 p.m, setting before midnight. However, each evening it will become visible progressively lower in the west until the end of the month. It will become lost in the dusk after evening. It will then take a pass behind the Sun to reappear in late January as the morning star in the east before sunrise. Mars has now completed its pass. That was Venus, yep. Mars has now completed its pass behind the Sun, but is too close to be visible this month. Jupiter, the third brightest object in the night sky after the Moon, and Venus will be visible in the northwest from just before 9 p.m. in the fading twilight, before setting around 1 a.m. early in the month. By mid-month it will set around midnight, and by month's end it will be 3:30 p.m. It will end, be setting at 11:30 p.m. Saturn remains easy to spot between Venus low in the west and Jupiter high up in the northwest. In early December it will appear in the twilight shortly after Jupiter and lead Jupiter towards the horizon by midnight. The yellow-tinged second largest planet will set earlier each night until the end of the month. It will be gone by 10:45 p.m. The triple lineup, Venus, Saturn and Jupiter. As was the case in November, 3 of the 5 visible planets will continue to appear in an impressive line in the western evening sky. They will be in Sagittarius, Capricornus and Aquarius, with Venus low in the west, Saturn midway and Jupiter high in the northwest. A bonus addition to the lineup this month will be the Moon. From the 10th it will be to the right of Jupiter in the west as a crescent moon, reaching the first quarter on the 11th. Each night after that it will be further to the north as it transitions to the full moon in the east on the 19th. Over a week or so you can both enjoy the planetary lineup and observe our lunar neighbour changing phases. Meteors. This month is time for the Geminids, that's the word. This month is the time for the Geminids, which peak on the night of the 13th and the 14th. They are a consistent source of meteors and appear in Gemini in the northwest with the bright star Castor. Most meteor showers result from Earth passing through the debris trail of past comets that is, but the Geminids are associated with the asteroid Pantheon, which orbits the Sun every 1.4 years. In an hour in good viewing conditions, you could expect to see anywhere between 40 to 120 meteors. A handy visual guide for meteor showers has been produced. Although created this year, all details will remain the same for 2022 except for moon phases. There's a calendar here. I haven't brought that up on the screen, but if you go to Sky Notes for December, you'll see the meteor shower calendar that's been produced. Alright, keeping an eye on the time. It's 18 past the hour. I'm just skipping the constellations at the moment. The International Space Station. The ISS orbits every 90 minutes at an average distance of 400 kilometers, appearing like a bright star moving slowly across the night sky. Here are some of the brightest passes expected this month over Melbourne and central Victoria. On the morning of Wednesday the 15th, there's a passing at 4:55 a.m. to 5:01, coming in from the west southwest to the north-northeast. Then on the morning of Thursday the 16th, the next day in fact, there's another passing at 4:07 a.m. to 4:14 a.m. southwest to northeast if you are up that early in the morning. Then on the evening of Sunday the 12th, there's a passing at 10:21 p.m. to 10:28, coming in from the northwest to the southeast. On Thursday the 30th of December, there's a passing at 10:46 p.m. to 10:49 p.m, coming in from the west-southwest to the north-northeast. And then by the end of the month, on the 31st of December, Friday, there's a passing at 9:58 to 10:04 p.m, coming in from the southwest to the northeast. For further dates and times for passings of the International Space Station and just for just about any other celestial object in the sky, go to the Heavens Above website. Heavens Above gives predictions for visible passes of space stations and major satellites, live sky views and 3D visualizations. Be sure to first enter your location under the configuration file to get more accurate times. You're tuned to VK3 EKH, the official station of the Astronomical Society of Victoria. And I'll just throw in 3 dates. 3rd to the 3rd, because they've got a few here. On the 1st of December 1922, solutions to Einstein's equations for space-time and mass energy are developed by Alexander Friedmann. On the 2nd of December 1915, Einstein's general relativity is published on gravity acceleration equivalence and space-time curvature. Also on the 2nd of December 1971, Mars 3 USSR, first soft landing and return of data from Mars. On the 3rd of December 2014, JAXA Explorer Hayabusa 2, Japan, is launched to asteroid Ryugu with a planned sample return to Earth. Also on the 3rd of December 1973, Pioneer 10 makes the first flyby of Jupiter and returns the first close-up images of the planet. Okay, so now what we will do is go into the interview with the podcast interview with Brendan O'Brien, talking to John Circassian, part 2 interview, which we had part 1 last week, and so this is part 2. I'm not sure how long it goes for, but let's hope it doesn't get too much into tonight's session. So stand by for the session from the podcast. Thanks to Brendan for allowing us to play the interview. So let me see if I can get this up. I'll cut to the slide, and then I'll bring up the audio file. Stand by.
Sarkissian, in part 1 in episode 17, told us about his inspirational viewing of the moon landing in 1960.
All right. Oh, yes. Now I don't know why it did work. Just before I went to air, I had that all nicely queued up, and for some reason I go to play it. Like I restart that file, I hit play, and it just jumps straight to the end. How annoying! Just things like this just don't need to happen right at this moment. What I will do is just search for the audio again. I think that's it there. So I'm just passing it across to vMix, and I've just reloaded it, and let's see if it's going to. Yeah, now it seems to be playing. I've just got to jump forward a little bit for this to work, and just stand by. We might have it in a second. VK3 EKH audio
before, because it will be built here.
I've seen photos of initial instrument. We finished about his inspiration.
Just queuing it up. It should start any second. This is VK3 EKH with a little bit of echo. Stand by until I hear this. We'll start any second. Any second. VK3 EKH, official station of the Astronomical Society Victoria. Just waiting for this track to start. Any second it'll kick off. It's playing. I can see it's playing. Oh my god, fella. Any second. Alright, hang on a second. Let me see if I can just click this forward a bit.
The initial instrument rating of the Parkes dish, so that it now has exceeded its planned operational lifetime by 35 years and is also 10,000 times more sensitive than the initial instrument. We finished this episode discussing Australia's role in the SKA, the Square Kilometre Array, and the CSIRO's ASCAP Pathfinder instrument. Here, in Part 2, we revisit the CSIRO Parkes Observatory, known affectionately as the Dish, since it relayed those iconic Apollo television images that showed Neil Armstrong taking one small step. And we speak again with John Sarkissian, the operations scientist. Now, we continue our discussion and move on to look at the spider dipoles that make up the Murchison Wide Field Array in remote Western Australia. So let's fast forward to that point. I've seen photos of spiders.
Okay, the spiders are called dipoles. They're just little low-frequency antennas, if you like. As part of the SKA, the big instrument that we're building, because we missed out on hosting the main array, as a consolation almost, if you like, we were given the low-frequency array, which will be observing up down around a few hundred megahertz frequency, much lower frequencies. And so the low frequency array, and that'll be just adjacent to our ASCAP array of those 36 antennas, and we'll be ramping that up in the next few years also in the phase 1 construction of the SKA. So even though the main array will be built in South Africa, the low frequency array will be built here in Australia at our preferred site where our ASCAP antennas are.
And we don't like making predictions, John, but we can certainly predict there's going to be some unexpected discoveries made with this new technology.
Oh, it will. Almost, I won't say guarantee it, but it is expected, because in the history of astronomy, in the history of science, period, whenever you observe in a new parameter space for the first time, you make discoveries. And that parameter could be, for example, a different frequency, it could be a higher magnification, or it could be greater sensitivity or higher time resolution, or whatever it happens to be. Because the SKA and ASCAP and even the low frequency array will be extremely sensitive instruments, where we'll be sampling, if you like, an entirely new parameter space, and we're pretty confident that we will be making discoveries. Now, what they are, we don't know, but we're confident that we're going to find something that we didn't know of before, because, things are always lurking in the parameter space. If you're the first to observe in that particular parameter space, you'll be the one making the discoveries, and then everyone else can. When it was around 300,000 years old and so on. We want to know what the universe was like at that time. But also, its great sensitivity means that we'll be able to do in other galaxies, like Andromeda, for example, the Andromeda galaxy, M33, what we can do in our own galaxy with our current instruments, So we'll be discovering pulsars and other things in the neighboring galaxies that we currently can't do because they're just too far away and the signals are just too weak. But with SKA being much more powerful, more sensitive instrument, we should be able to observe those things in other galaxies. Of course, for the objects in our own galaxy, we'll be able to do it even better, see it with even higher strength, even greater sensitivity and so on. So it's an exciting project, which is why we've been pushing it for the last 20 years or so to get it. So finally, things are starting to come together, and that's really great. When I first started here, one of the first roles I had here was to investigate the sites around Australia for the best location to put this thing. We wanted a very radio-quiet area, and I did some computer modelling of various transmitters around Australia to find where the most radio-quiet place in Australia was. And we pretty much settled on the Murchison Shire in Western Australia because it is extremely remote and very, very radio-quiet. And that's where we're building everything. So to finally see things actually being built there is really satisfying.
It's fantastic. And a lovely segue to the idea that we get unexpected discoveries with almost from the moment that LIGO was turned on, they discovered gravity waves. Now, you're doing a bit of gravity wave research with pulsars at Parkes. Can you tell us a little bit about that and whether you see it as heralding a new science of gravitational wave astronomy?
Yes, throughout history, everything we've learnt about the universe has come from the electromagnetic radiation. Originally in the visible wavelengths, and then about a century or so ago, we started using radio and detected cosmic signals from beyond the Earth. And then with the space age, we went to ultraviolet, infrared, gamma ray, X-ray, and so on. But the only way we could get information about the rest of the universe was through the electromagnetic radio, from the electromagnetic spectrum. But with gravitational waves, it gives us the opportunity to study the universe in an entirely new regime, away from the electromagnetic spectrum to the gravitational wave spectrum, if you like. And Einstein's theory of general relativity predicts that when massive objects are accelerated, they will emit gravitational waves. And as they emit those waves, energy is taken out of the system and gets dispersed throughout the universe. So if you could figure out a way to measure those gravitational waves and detect them, then you can actually study phenomena in the universe that you can't do with electromagnetic radiation. So, for example, if you have two supermassive black holes orbiting about each other in the centres of galaxies, for them, two colliding galaxies, then that would take several weeks or months or even years to orbit about each other. Yep. So the frequency of that gravitational radiation would be very low. Periods would be very long. So it would be months or years in periods. Yep. But if you have black holes or neutron stars orbiting much closer together, they're spinning around quite rapidly, orbiting about each other. So the frequency of those gravitational waves will be much higher. The period's much shorter. And of course, at the moment when, say, two black holes suddenly coalesce, get sucked into each other gravitationally, then you'll get an extremely high frequency gravitational waves being emitted. And so you can study different phenomena just at different wavelengths, if you like, of that gravitational wave spectrum. LIGO was designed to study the high frequency gravitational waves, like the moment that two black holes were suddenly coalesced and formed a more massive black hole. Yep. And so about this time last year, actually, September last year, when they upgraded it to its final sensitivity and switched it all on, 2 days later, they detected the coalescing of those two black holes. And in that split second that the black holes coalesced, they radiated the equivalent of 3 solar masses in gravitational energy that could be detected clear across the universe with their instrument. What we're trying to do here at Parkes is detect the low-frequency gravitational waves, if you like. Okay. Long period stuff. So, for example, it's where you have these two supermassive black holes in the centers of distant galaxies, slowly orbiting about each other and emitting this long, sedate gravitational wave away from it. And we're doing that Well, the way you try and detect gravitational waves is you try and see how space expands and contracts as the gravitational wave passes through your test instrument, if you like. Okay.
Yep.
Gravitational waves are extremely weak. They have a strain of 10 to the minus 20 or 10 to the minus 21. By that we mean that if a gravitational wave were to pass between, say, a 1 meter long ruler, then depending on whether it was a peak or a trough, that 1 meter ruler will expand and contract 10 to the minus 20. That's the difference in its length.
Yep.
Okay, which on that scale would be 1,000th the diameter of a proton. Very, 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 very tiny expansion and contraction, okay? And so that's why with LIGO, they had to do really clever things with a 4 kilometer long arm, if you like,
yep.
with mirrors in a vacuum with lasers going back and forth and interfering with each other to try and detect the oscillations. It's extremely, extremely weak. But what we're trying to do here is we actually use pulsars to try and detect the longer frequencies of gravitational waves. Pulsars are these really compact, dense remains of really massive stars that have exploded. They're only about 10 or so kilometers in diameter, but they have about 1.5 times the sun's mass packed within that tiny volume.
Yes.
Extremely dense. These incredibly powerful magnetic fields, hundreds of millions of times more powerful than the Earth's magnetic field that surrounds us now. And emanating out through the poles of these pulsars is a beam of energy. And as the star rotates, this beam sweeps out across space like a lighthouse, if you like. So if by chance the Earth lies in the direction of the beam, then each time it sweeps by, we detect it as a pulse of energy. It goes boop, boop,
yep.
boop. Hence the name pulsar.
Yep.
But because these stars are so massive, they have incredible angular momentum, and so nothing's going to really slow them down very much, okay? They're very, very stable. And so you can think of those pulsars as being like ticks on a super accurate clock.
Yes.
If you're observing a pulsar and a gravitational wave were to pass between us and the pulsar, the space between us would actually expand and contract.
Yep.
And so that when it expands, it's further away from us, it'll take those pulsars a few nanoseconds longer to reach us.
Yes.
If it contracts, they'll actually arrive a few nanoseconds earlier than expected, okay? So you should be able to see the oscillation of this pulsar moving away and towards us over time. And so if you can view about 20 or so pulsars distributed across the sky every 2 or 3 weeks or so, then over time you should be able to detect the fact that in one particular direction, the pulsars are arriving sooner than expected, and 90 degrees on either side, they should be delayed by the same amount.
Yes.
And so you can use that to try and detect directly gravitational waves. You use the space between the Earth and the pulsar as the rod, if you like, that long rod with the 2 test points, the pulsar on one and the Earth on the other, and measure the distance expanding and contracting between them. Very much like LIGO works. You have the 4 kilometer long arms, they expand and contract at 90 degrees to each other, and so you can then use that to determine if a high frequency gravitational wave went through. But because we have to observe pulsars over several weeks or months, then we're more sensitive to the lower frequency, the longer period gravitational waves. Because we're studying supermassive black holes in the centers of colliding galaxies. LIGO is looking for the higher frequency gravitational waves where black holes are coalescing that instant before they coalesce.
So you've got a sort of directional radar there going, John, and does that mean that after you've done some detection and identified the direction, then you'll direct other instruments and look for the source of those gravitational waves?
Yeah, unfortunately, the directionality is not very good. You can have a general idea of what part of the sky it's coming from, but not enough to say, it's coming from that particular star or that galaxy. Okay, it hasn't quite reached that point. Difficult to actually be able to do that. But you will be able to say, for example, okay, we're detecting this many supermassive black holes in the universe. So that tells you something about the universe.
Okay.
And the same with the coalescing black holes. If you're detecting 2 or 3 a year, that tells you how numerous they are up to a certain sensitivity. But what we're also hoping to do is to use that information to test the various competing theories of gravity. Einstein's theory predicted a certain level of signal strength, if you like. Other theories have predicted different signal strength. And so we've already been able to, from our observations, exclude some theories of gravity. Because if they were correct, we should have been able to detect the presence of gravitational waves already. We've been doing this now since 2004, so we've been going for 12, 13 years. And so we haven't detected the gravitational waves yet, the background gravitational waves yet, but we have been able to use it to exclude other competing theories of gravity. So to date, Einstein's theory is holding up. It's still there, valid. LIGO's observations confirmed it beautifully. Okay, so we were hoping before LIGO made their announcement that our observations, it's called a pulsar timing array.
Yep.
And we were hoping that the Parkes pulsar timing array would be the first to directly detect gravitational waves. So they pipped us at the post on. We think that we're a few years short of building up enough observations to get the sensitivity down to be able to say definitively that we've detected it. But then again, we're doing it on the cheap in comparison. LIGO's a $1 billion project where we spend maybe a few $100,000 a year on ours.
That's really sensational. Now, on a lighter note, can you tell us about FRBs and peritons and microwave ovens?
Yeah. Well, FRBs were discovered here at Parkes. Again, in the course of the multi-beam surveys, the pulsar surveys, we recorded a lot of data. And in 2007, Duncan Lorimer, a British astronomer, was sifting through some of our archive data dating from 2001.
Yes.
Looking for giant pulses from pulsars.
Yep.
And he came across a single really powerful pulse, but it was only a single pulse. It lasted just a millisecond or two and very, very strong, but it was highly dispersed. Dispersion is when the electromagnetic signal travels through a dielectric medium, if you like. Its velocity will change with wavelength or frequency. And so you see the signal being smeared out with frequency, if you like. It's called frequency swept. The more that the signal is dispersed, then it indicates that the more distant this object must be because it's traveled longer and had more time to be dispersed. And so he found this object that suggested that it was coming from extragalactic sources. It was extremely strong, but it was in a single observation from 2001. So when he notified us in 2007, we observed that same position again for many, many days and never saw another signal. And so it was dubbed the Lorimer burst as a result, but it remained a mystery until about 2010 when some other astronomers sifting through some archive data found more of these things, and they also found it in new observations. And again, they were highly dispersed and they indicated they were coming from very, very distant extragalactic sources, billions of light years away. But their origin was a total mystery. We're pretty confident that they're coming from extragalactic sources because we're using the multi-beam receiver. We're looking at 13 points simultaneously. If it was some local radio interference, like, say, a microwave oven or something, for example, we would see it in every one of those beams because the instrument will illuminate the signal in all of those little receivers in the multi-beam receiver.
Yep.
And so, but because we see coming from just single beams on the sky, it indicates that the signal must be coming from the direction that beam is pointing and not the one adjacent to it and so on.
Yes.
So we're pretty confident these things are cosmic in origin and they're very, very distant. Okay. However, during the course of that, astronomers, again, sifting through our archive data, detected signals that mimicked what we call these fast radio bursts in very closely, but we could see them in all beams, the multi-beam receiver, which indicated there had to be local interference.
Okay, yep.
We had no idea what instrument was creating because we were detecting at 1.4 gigahertz at the 21 centimeter hydrogen light, which is what the multi-beam was designed to detect. So we had no idea what it was, but one clue was they seemed to be clustered around lunchtime and dinner time. And we're thinking, geez, either the stars operate at civil time or it's something that's operating. And so our first suspicion was microwave ovens, but microwave ovens operated 2.45 gigahertz, almost double the frequency of detecting it. And when we tested it, we could never we could never reproduce it. So we said, it's not the microwave oven. So it remained a mystery for many years. But then in December of 2014, just under 2 years ago, we installed a new real-time radio frequency antenna here at Parkes that would scan the site every 20 minutes and update the data every minute. And it just so happened that in January, just 1 month later, astronomers here had developed some new software that allowed them to detect these FRBs in near real time. So when something happened, they could be alerted very quickly and then try and follow up with other instruments if they can.
Yep.
But on 3 successive days, they found these peritons appeared, again, around lunchtime. on each day. And we thought, geez, that's all right. So when we looked at the data from the real-time radio interference antenna, you could see the signature at 2.45 gigahertz of the microwave ovens come on and then switch off again, a minute or two later, which seemed to coincide with the time you'd heat your lunch and so on, okay? So we thought, that's curious. So we tested it again, and we still couldn't reproduce these peritons.
Yep.
Peritons, these things were dubbed peritons by Sarah Burke, who was a PhD student who found these things because it's named after some mythical creature that mimicked some other creature or something.
Right.
So it was a nice name, so it sort of stuck.
Yep.
But we couldn't reproduce these peritons, and so no matter what we tried, I was out there with the microwave ovens, turning them on and off. We could see them come on, but no peritons. And then a colleague of mine, Dr. John Reynolds, had a sleepless night thinking about this, and he thought, what would happen if you were to pop open the microwave oven door while it was still operating? In other words, you didn't wait for it to stop.
Yes.
As you normally do. You're not supposed to do that, but, some people do. They're very hungry. They can't wait. So I said, okay, we've got an hour of free time that evening. Let's try it. So when we went in there, I started it up, and then before it had finished, I popped open the oven door, and bang, we saw peritons.
Yep.
And then every time after that I'd do it, we saw peritons. Because, oh, God, it's the bloody microwave ovens. Okay. We found the cause. And it's to do with the way, as a safety thing, the ovens are designed to immediately shut down the magnetron, the microwave magnetron, so that, you don't irradiate the people
Yes.
who are hungry. And so somehow in that process of shutting down for safety reasons, it produces this frequency swept signal that looks like a dispersed FRB signal.
And that's why you've set up at Murchison.
Exactly. That's why we don't want people visiting there, because as soon as you introduce interference, because in the Murchison, it's bloody hot in summer. It can get up to 50 degrees. You'll need air conditioners. You have to feed them. You have to communicate with them. Even the cars that they use to get there, or the planes or whatever, will all produce radio interference.
And you've got to give them microwave ovens too, John.
Well, if you want to cook things. So we found that, and so we felt, even though we're not hopeless people, we could see the humour of the situation. So we wrote the paper to explain the source of it, not so much to cover us, but to let people know that if they see that, get rid of their microwave oven so it doesn't confuse you from the real source that we're trying to find, the FRBs, because we think the FRBs are real. Since we removed all the microwave ovens on site, we're still seeing them. And in fact, all but I think 2 or 3 of the FRBs discovered have been found here, including the very first one. So in many ways, it's an extremely satisfying situation because we have no idea what's producing these FRBs. They could be coalescing neutron stars, or an exploding something somewhere.
That was coming up to the end of that interview anyway, so it's just decided to cut itself short. Okay, fair enough. Anyway, all right. So that was part 2 of the interview with John Sarkisian, and lots of interesting things there, particularly the story about the microwave oven causing issues with the dish. Anyway, that was done a few years ago, that interview, so basically we've come a little bit further with FRBs, and there's been many of them found, and there's been just a handful that are repeaters, so to speak. Anyway, that's another story. Alright, this is VK3EKH, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast, and you have just been listening to an interview, part 2 interview with John Sarkisian, the operational scientist at the Parkes Radio Telescope. And do apologise for the lack of audio at the start there. Like I say, I always edit the audio, the interview, out of the program that Brendan O'Brien does at astrophys.com. Goes for an hour. Easy, it goes for an hour, and the interview sits in the middle of all that, so I try to take out the interview so it's separate, and I did that just a little bit about 9:15 today, and did play it up a little bit, which is nothing unusual for this sort of medium that we're in. enough of that rubbish. Okay, it's coming up to 10:02, so we'll go across to Tamitha with the latest solar report, and hopefully we won't have any problems with this interview. So stand by for that.
We have a partially Earth-directed solar storm that looks like it could graze Earth to the south, and some coronal holes could bring us some fast solar wind as a chaser. Those stories and more in the news this week. This space weather forecast is sponsored in part by Millersville University. Come get certified in broadcast space weather. Visit millersville.edu/SWEN. Space weather this week is definitely keeping us on our toes. As we take a look at our Earth-facing sun, you can see lots of bright regions in the southern hemisphere, and this is good news for amateur radio operators and emergency responders because these regions are boosting that solar flux and keeping radio propagation in the marginal range on Earth's day side. And it looks like those conditions will continue for at least the rest of this week. The nice thing is, though, that these regions are not flare active, so we don't have to worry about big radio bursts bothering radio communications on Earth's day side. Now, as we also take a look, you can see several finger-like coronal holes. These coronal holes are going to be bringing us some fast solar wind. We've got one pocket that's going to be over the next couple days, and then we're going to wait a little bit, and we're going to get another pocket from that crescent-like shaped coronal hole that should be bringing us some fast solar wind, probably around the latter half of the first week of December, and this could bring aurora possibly down to mid-latitudes for a short period of time. And then there's one other cool thing is that on the 29th, whoosh, do you see that? That was a solar storm that was launched. Now this solar storm was actually launched to the south of us, and you can see that in the coronagraph images. You can see this almost partial halo that goes to the south, but this solar storm looks like it might actually have its northern tip graze Earth sometime around late on the 2nd or into the 3rd, and we'll definitely talk more about that in a minute. Meanwhile, as we go and take a look at our far-sighted sun, this is stereo A, and it's looking at the sun just a little bit from the side. You can see that big finger-like crescent coronal hole that's going to be rotating into the Earth strike zone here over the next, week or so, and that's going to be the fast wind chaser for that solar storm. And then if we take a look behind it, we see a little bit of activity both in the north and in the south, and these are new bright regions, likely going to be reasonably quiet, and probably not big flare players, but they will continue to boost that solar flux, so radio propagation should remain pretty good on Earth's day side. Switching to our prediction model Enlil, now this is NASA's version of the model, and you're looking down at the sun from the North Pole with Earth being off to the right. And as you take a look, you can see that solar storm being launched. You can tell it's not a super strong storm. As a matter of fact, as we step off and you can actually see the north-south cut, you can see that the storm is actually moving off to the south. Just the northern tip of it is going to graze Earth. But remember, we also have that coronal hole with that fast solar wind, and that could actually push this storm even further south, so it might actually miss Earth completely. But nonetheless, if it actually does graze Earth, it should happen sometime afternoon on the 2nd and possibly into the 3rd. But we're not expecting a big disturbance. But if you are an aurora photographer and you're dedicated and you want to take a chance, well, we do have a possibility for aurora. Switching to NOAA's version of the model, the top panel's density, the bottom panel's velocity. Again, we're looking down at the sun from the North Pole with Earth off to the right, and you can see that solar storm coming out. It looks a lot more wispy in NOAA's version of the model, but again, as we step back, you can see the reason why is we've got most of that solar storm going south of us. But in NOAA's version, it looks like the impact is going to be late on, or about midday on the 3rd and into the 4th. So we do have a bit of a discrepancy here. So anytime we've got from basically midday on the 2nd in through the 4th, we could be seeing some enhanced storming, especially at high latitudes with a fast wind. Boy, that could give us a decent chance for aurora, even a skosh of a chance down at mid-latitudes. Switching to our moon, we are now passing through the 3rd quarter phase on our way to a new moon, with the new moon being on the 4th. So you night sky watchers, if you want to catch those dim objects in the sky, like, I don't know, maybe some aurora, well, now would be a great time. Switching to your solar storm conditions and aurora possibilities over the coming week, we are anticipating the glancing blow from that solar storm that's headed towards Earth, but could likely go mostly south of Earth. But at high latitudes, NOAA is expecting minor storm conditions with up to about a 65% chance of a major storm. And if you notice, there's a little bit of activity all throughout the week. And this is due to the fact that we've got some fast solar wind that's beginning to hit now. And we're going to have that solar storm hit. And then after that, we're going to get another pocket of fast solar wind kind of as a chaser. So we could have some decent opportunity for aurora at high latitudes easily through most of this week. So enjoy. Now, mid-latitudes, the story isn't quite so rosy. We are getting a little bit of disturbance from that fast solar wind up front now. So there's a tiny chance for aurora at mid-latitudes, but then when that solar storm ends up grazing Earth right around the 3rd, we could jump to active conditions with up to about a 25% chance of a minor storm, and then we should settle down just a little bit slowly because we'll have that fast wind chaser as well, but the wind shouldn't be all that fast, so we do get maybe some sporadic chances of aurora at mid-latitudes, nothing like what we'd have at high latitudes, so only dedicated aurora chasers at mid-latitude should you bother, because I don't want you to get too disappointed when things may not be quite as strong as you would hope them to be. Switching to your solar flare and particle radiation storm outlook over the coming week, believe it or not, over the past 24 hours, we've actually seen a little bit of complexity emerge in some of these bright regions. In fact, region 2900 is showing a little bit of chance for big flare activity, and we've had a couple new regions emerge on the Earth-facing disk. So NOAA has upped the big flare risk. We've got about now a 5% chance of M-class flares over the next few days, mainly due to region 2900, but it looks like regions 2902 and 2903 might also provide a little bit of flare risk here as the days wear on. The nice thing, though, is that all these new regions are allowing the solar flux to maintain itself in the low 90s. We are still in the almost good range for radio propagation on Earth's day side. So amateur radio operators and emergency responders, enjoy this. It's easily going to last throughout this week. Now, also because we are still climbing out of solar minimum, we are still getting a bit more cosmic ray flux than we'd like. So you frequent flyers, and this does include aircrew who fly over 800 hours annually and fly at high latitudes and high altitudes. You are in the moderate range for radiation dose. This is the D2 minor range, and it does include prenatal passengers, so please take this into consideration in your flight plans. So the space weather this week is definitely keeping us on our toes. We have a solar storm that looks like it's coming toward Earth, but maybe it's going to go south of us and just give us a grazing passage, but it seems to be kind of sandwiched between fast solar wind both before it and after it. So aurora photographers, if you're at high latitudes, you could definitely get a little bit of a show, kind of a low boiling disturbance throughout the rest of this week. Whereas at mid-latitude, if you're, aurora photographer, perhaps you should chase only if you're dedicated, because aurora will likely be fleeting and sporadic. But we could get the most intense show if there's going to be one sometime around the 3rd. Now, amateur radio operators and emergency responders, hey, the news isn't quite so bad for you. We only have a small M-flare risk, so the risk for radio blackouts is pretty mild, but we are managing to stay in that marginal range for radio propagation almost into the good range, because solar flux is maintaining itself in the low 90s, and that's going to easily continue with all these new bright regions beginning to emerge. So enjoy. And now you GPS users, well, we've only got that grazing solar storm passage, and we don't seem to have a lot of disturbance, so as long as you stay away from the dawn-dusk terminators and away from aurora on Earth's night side, your GPS reception should be pretty good. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Okay. You're tuned to no audio. There we go, plenty of audio now. You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast from VK3CSJ in Narre Warren South. And thank you, Tamitha, for that very quick rundown of the latest in the solar side of the scene. It's amazing how the hour goes when you're having fun, and apart from all the articles that I had just ready to go in case I had an odd 10 minutes to spare. Of course, we've run short of time, so that's okay by me. As far as space weather goes, as a quick rundown from what spaceweather.com indicates, the solar wind is currently at 458.6 kilometres a second at a density of 9.9 protons per cubic centimetre. There's 2 sunspots, actually I think there's 3. There's 2 on top of each other here, but basically there's 2 or 3 sunspots on the disk of the sun as we speak. Current sunspot number is 45, and the radio sun is currently at 87 solar flux units, measured at a wavelength of 10.7 centimetres. Okay, and that's about it there. And currently there are 2,241 potentially hazardous asteroids out there. Alright, with all that, we shall now conclude the session for tonight. And I hope that oh dear, excuse me, I hope that people have found it of some value. Thanks to Dave VK2ELS for emailing in there, and Andrew VK3KIS, and Don VK3HDX. Ian has also VK3VIN emailed me, and Steve VK3NFS also indicates that I'm a thumping signal up in Wodonga area tonight, so thank you for that, Stephen. And also to John VK3BLX, who's listening and watching on the TV. G'day John. And Martin VK7JAH. That's about all that came up on the chat window tonight. I don't know where everybody's been, but only a couple of people popped up on the chat window tonight. Usually there's at least 4 or 5 folks there. Never mind. So that's it at 11:01. You've been listening to yet another broadcast from VK3EKH, the official station of the Astronomical Society of Victoria. All information about the society can be found at the website at www.asv.org.au. And this time next week, folks will be getting ready for the Starbecue up at the Heathcote website. I don't know if there's any more tickets available, but to be able to gain access to the Starbecue, you have to get a ticket organised via the website on the homepage there. It's all to do with the COVID restrictions and all that sort of stuff. It's still in force. So yes, I'm not sure, but I hope to be up there myself next Saturday as well to see how things are progressing, because it's been something like 20 months since I was last up there. Anyway, I'll be here next Friday for another broadcast. So standby stations on 80 metres for a quick callback, and folks listening on 160, if there is any, thank you for listening, and we'll be back again next week to do it all again. So standby stations on 80 metres. This is VK3EKH, official station of the Astronomical Society of Victoria, concluding transmissions on our medium wave service on 1865 kilohertz. Cheers to everybody there. Standby stations on 80 metres. Alright, so that's the 160 metre service shut down. And okay, I've got my pen and paper. Yep, right. So if anybody is wanting to call in, please come up on 80 metres now. This is VK3EKH listening. Alright, there was a jumble of stations there, but I got VK3YJQ, VK3JR, and who else is there?
VK3VIN. VK3 November Foxtrot here. VK3 Hotel Delta X-Ray. VK2 Echo Lima Sierra. VK7JAH.
Beautiful. All nice and separate, that's good. Just a sec, writing the last one down. Okay, so we've got VK3YJQ, VK3JR, VK3VIN, VK3NFS, VK3HDX, VK2ELS, and VK7JAH. Is there anybody else?
VK3 Tango Juliet Sierra. Victor Kilo 3, Kilo Italy Sierra. VK 5, Whiskey Alpha.
Excellent. Okay, VK3 TJS, VK3 KOS, and VK5 Whiskey Alpha. All right, to the top of the list. G'day, Steve. VK3YJQ, VK3 EKH.
VK3 EKH, VK3YJQ returning. Very good, Clint. Good evening to you and good evening to everyone else on frequency. All good signals coming in tonight. You were excellent copy all the way through that session. Here, good 30 over 9, 30 to 35 over 9. Excellent copy, armchair copy. A little bit of static in the background between breaks, but nothing particularly to worry about. Good evening to you, Frank. It's been a while. I've been down off the system for quite a while because the cockatoos chewed up my antenna system and I wasn't able to do repairs until we got out of lockdown. So I'm back on air again. Hopefully the measures I've put in place to stop the cockatoos coming back and doing their damage again will last. I've put in a few scarecrows and things like that. Won't go into details there. There's a big group tonight, so I'll try to keep it brief, Clint. Interesting, very interesting interview there with John Sarkissian. Look, I'm ashamed I missed part one. Looks like this is a pretty good, interesting series. Part two, certainly with some thrilling information. Parkes have got the terrific title of Parkes Pulsar Timing Array to do gravitational ray studies at 1.4 gigahertz, no less, Clint. That's interesting stuff, isn't it? Because our receiver's going to be working at that frequency very soon, up at Heathcote. Very interesting. And slow gravitational wave detections rather than the super fast ones where you get collisions, like the neutron star and black hole colliding and two black holes colliding. That's the fast detection stuff, but Parkes is doing this slow detection. I haven't heard of that before, so that was a revelation there tonight, Clint. Thank you for that. Look, I won't hold it anymore. There's lots of other things to mention, but I usually do a little bit of an update on the exoplanets because I've got that application on my mobile phone, and it has done quite a few updates since I was last on a few months ago. And I can't remember the last value I quoted, but it might have been around the 4,000 mark, but we're now up to 4,604 confirmed exoplanets. 4,604. So I'll leave that with you. Thanks again, Clint, and nice to hear all the other guys on frequency too, and the VK2s and the VK5s and so forth. All good stuff. Put it back to you, Clint. VK3 EKH to take it. VK3 YJQ.
Very good. VK3YJQ, VK3 EKH. Excellent signal, Steve. You're 5 and 9 plus 25 and holding there nicely, so your antenna is working fine. You always put out a good signal when you come up on 80 metres, so yeah, not too bad tonight at all. And yeah, I've been working through the podcasts from Brendan O'Brien from astrophys.com. So there's well over 100 podcasts that he's done, and in fact, just a couple of weeks ago, I ran his most latest podcast that had an interview with Jill Tarter of the SETI fame, and that went across very, very well indeed. I try to quickly listen to these podcasts before they go to air. I had no time tonight to do it, but I find that a lot of the podcasts have a lot of digital artifacts associated with it. It's not the best of recordings. What I actually hear in the shack on my headphones, for instance, via the mixer doesn't sound too bad. But unfortunately, the narrow band aspect of our SSB transmissions tends to knock the sibilants about a bit, and can be a bit tricky to for folks listening on 18 metres or 160 or what's going on. But if you listen to the repeater, the audio feed off the television repeater and or the YouTube stream, of course it's much better quality through there as well. Nevertheless, thank you for listening, Steve, and we'll probably see you next Saturday up at the Dark Sky site, so should be an interesting afternoon up there. Be nice to see the site. I haven't been up there for a long time. Hopefully the weather will play nice too. very, very unpredictable at this stage how the weather's going to behave. Thanks, Steve. All right, across to Frank, VK3 Juliet Radio, VK3 EKH. Yeah, there, Frank. VK3JR, VK3 EKH. Alright, looks like he's gone away. I'll call him in a little later. Across to you, Ian, VK3VIN, Kangaroo Flat, VK3 EKH.
Yeah, g'day, Clint, VK3EKH, VK3VIN. I missed the first 10 minutes of the broadcast, but the rest of it was terrific. And the interview, the audio I thought was better than what I have heard from previous podcasts. And that's partly because I was listening to it on a wide filter, but partly because it the band wasn't phasing when the interview was happening. So it was nice and quiet without any phasing, and that made the audio a lot easier to hear. Yeah, a good broadcast overall. And I always enjoy the space weather. And let's hope the predictions are right in terms of conditions. 40 metres has been very ordinary during the day in the last week or so. And but shorter signals have been coming through quite nicely. But they come and go very quickly. Clint, they're not there 1 minute, then they come up with strength 9, and then 30 seconds later they're gone again. So it's very interesting on 40, and 80 metres has been waking up at night. Around about 7 o'clock local time, the signals are becoming quite audible. And that's quite a distance, quite a deal of time before sunset. And enjoy the barbecue and the festivities at Heathcote. It almost seems appropriate to autograph hunt. So I'll see if I can find something to, if I was going, I'd find something for you to sign. I don't know what. Out of the ordinary would be good. You report 20 to 30 dB over 9. Yeah, all over very good. I don't know that I can get my head around black holes colliding. And the microwave. How fascinating was that? I didn't quite realise that microwaves were on the frequencies they were talking about. Anyway, very good broadcast, always enjoyable, and the first one for summer. VK3EKH, VK3VIN.
Wrong button. VK3VIN, VK3EKH returning, very good. You're 20 over 9, Ian, 20 over 9 down into Narre South. Good signal indeed. And the band is nice tonight. It's behaving itself. The lightning crashes are well and truly off in the distance. So it's quite good for local comms, that's for sure. Yeah, the problem, as John reports, the problem was that and I can't imagine why anybody would open up a microwave door before it's finished. it doesn't make sense to do that, because the magnetron's still firing away at 500 odd watts at a particularly dangerous frequency. It's around 2.46 something gigahertz, the maximum frequency used for molecular agitation, which causes heat and all that sort of stuff, whatever you want to call it. Anyway, why a person would open up a microwave oven just because they're impatient, and but that's what was happening. The microwave oven doesn't operate on 1.4 gig, but the effect of opening up the door before the magnetron had a chance to shut down correctly just caused an instantaneous spike that just threw the receivers at Parkes off scale, so to speak. And it took some effort before they finally found the culprit and the reason why. Yes, it's interesting stuff indeed. But apart from that, fast radio bursts are real. They do exist. They are happening all the time in the universe, and radio astronomers are finding new fast radio bursts all the time. New, maybe not so new, but at least finding different ones all the time. And the sky is literally full of them, really. It's just a matter of being in the right place at the right time to detect these instantaneous bursts of radiation, which never seem to occur ever again. So interesting how it works. Anyway, thanks, Ian. Good signal from you indeed. All right, and thanks for the report on the audio side of to the broadcast as well. Steve, VK3NFS Wodonga. G'day, Stephen. VK3EKH.
Yeah, okay, Clint. VK3EKH, VK3NFS. Yeah, 20 over 9, boys. You found it out here tonight. Very clear, very strong signal, no problem at all. And on the micros, I think we've all been guilty of it. Impatient people. But I think we've all definitely been down that road.
I've never done it.
I can't wait till I've got to have it now. But yeah, that's all good. Yeah, so that's about all. That's all I've really got to say. Good evening, everybody, and hope everybody's doing well. And everyone's, hope they're having a very fine beginning of summer. So back to you, Clint, and I'll let you roll on with it. VK3EKH, VK3NFS, over.
Good on you, Stephen. VK3NFS Wodonga, VK3EKH. Good signal from you too. 10 to 15 over 9 down here in Narre Warren. So yeah, good to really finally get a nice and decent signal from you indeed. And so you're the culprit, one of the culprits that opened up the microwave before it's closed, probably. Oh dear. Okay, all right. I'll put a special asterisk against your name for that one. Good on you, mate. That's I understand. Not a problem at all. I don't trust microwave ovens, but I use one almost daily. So there you go. Thanks, Stephen. Cross to Don. VK3HDX. VK3EKH. Have a say, Don.
Clint, VK3EKH and the group VK3HDX. Good evening, Clint. Good evening, everybody. Yeah, really interesting broadcast tonight, Clint, for the first of the summer series. Found it most interesting. I won't hold it. You've got a big callback list there, which is good. In a way, lots of people listening. Exceptional signal, 30 over 9 here, and really good audio on 160 tonight. I don't know if it was just conditions or not. I mean, again, very strong on 160, but it sounded really good. In fact, I listened to it on 160 more than 80. Cranked the volume up and sat back. It was very good. Thanks for the broadcast as usual. VK3EKH, VK3HDX.
Thanks, Don. That's what I want to hear. Those sorts of reports. VK3HDX, VK3EKH. Yeah, it's always worth listening to the SSB transmissions here on wide bandwidth, as wide as possible. It really does help to improve the clarity of the signal. Because I'm certainly with I'm only using the Pro 3s, the Icom IC756 Pro 3, and I'm using the wide mode functionality with the transmissions. Not that means I'm super wide, of course, but with a little bit of EQ on the system and all that sort of stuff, it tends to sort of pseudo enhance the audio, I suppose. Anyway, no, it's good. Actually, I did a bit of a fiddle halfway through the interview. I noticed a setting on the 160 meter transmission that wasn't quite right compared to the 80 meter one. So I gave that a bit of a tweak, and almost noticed immediately that it improved the level a little bit too. So I just had certain control down a little bit compared to the 80 meter one. Anyway, that's another story. Thanks, Don. Good signal from you. You're 30 over. You're the strongest into here tonight than everybody else so far. So, working very well indeed. All right, David, VK2 Echo Lima Sierra, VK2 ELS, have a say, VK3 EKH.
I sent you something, Clinton, which you may have still recorded on television. I used to be an astronomy teacher. I teacher of physics, which turns out that at the college down the way until I retired about 5 years ago. And I'm a fellow at the Royal Astronomical Society of London. And just before the broadcast, one of my contact papers sent me some information about our process of physics. It's only the GCSE, that's the English equivalent of GCSE, so we're not eligible for here. But I checked the information, and these eligible teachers, they may well be interested in teaching astronomy in the United Kingdom. They won't be eligible for the price of $100, but it's quite interesting. That's what it's the competition. And so the kids are required to submit posters under the stream. Actually, this is very cool. It's a bit certification one, this other one. People know in this case, there's another. And
VK2 ELS, VK3 EKH returning. All right, I only caught a little bit of that, not the whole lot, David. Something about time, about GMT, or something about to do with time, and something to do with Astronomy 101. I think it might be an article you're referring to. I'm not 100% certain, but I think it might be some article or something that you're referring to. If you'd like to send us the link to that article or what it was specifically you were saying, just send us a quick email, vk3ekh@gmail.com, vk3ekh@gmail.com. Just let us know what it was that you were referring to. I think it might be an article or a link to something that's associated with I think GMT, something to do with GMT, and I certainly heard the reference to Astronomy 101. So I didn't quite catch all that though, unfortunately, David. You're about readability 4 strength 9, readability 4 strength 9, which is kind of just above my noise floor here at this horrible place. It's noise floor is just atrocious sometimes. Anyway, thanks, David. Thanks very much for calling in, and just send us a quick email on that. I'll be interested to read and I'll respond as well. Okay. Next on the list here is Martin, VK7J. Is it Martin? Yeah, VK7JAH, VK3 EKH.
Signal level down here a little bit severe, and noise levels are very high, so I'm struggling a little bit, but hopefully you might be able to hear me. Over.
You're right on the 9, basically 5 and 9. I'll give you 5 and 9, but have a say, Martin.
I think you're about 3 out there, 3 about 9. Your levels are usually good, but I've suffered a lot from white coffee and a few other things like that, so I was probably a little bit over the noise level.
Righto, okay. Well, it sounds like you've also got a bit of an issue with the noise down there as well. you're about kind of like about the same sort of signal to David up there in Coffs Harbour. So about equivalent sort of signal with a little bit of difficulty there, but yeah. Well, if HF always is a problem, there's the YouTube stream. The YouTube works fine, and also I haven't quite got the audio stream working yet. I'm really sitting on that one. But anyway, thanks, Martin. Good. And I saw your email too, or your message up there about the Launch System Planetarium. Martin reports that the Launch System Planetarium is also active for those in Tasmania. Or visiting the Queen Victoria Museum and Art Gallery in Launceston between 11:30 and 13:30 tomorrow and Sunday. Yeah, so if anybody down there in well, if there's a lot of people in Tasmania, but if anybody is listening to me right now, for that matter, or is currently on the what's that ferry called now, Tasmanian Express or something like that, that goes between us, visit the Queen Victoria Museum and the Launch System Planetarium, which is all open between 11:30 and 1:30. Excellent stuff. One day I'll visit that. All right, thanks, Martin. Across to Jack up at Shipperton, VK3 TJS, VK3 EKH.
VK3 EKH, this is VK3 TJS. Thanks, Clean, and great broadcast and lovely signal from Europe all the way 20 over here in Shepparton. So it was very easy listening, and some of the stations come up with a good signal. David from Coffs Harbour was 59 here in Shep, but the station just before about 48 or something, so it wasn't easy listening. But thanks very much for the podcast, and hope we can share with you next Friday if I'm awake at that time. So all the best to you, and have a good barbecue in Hillstead. VK3 EKH, this is VK3 TJS.
Thanks, Jack. VK3 TJS, VK3 EKH. You're 5 and 9 plus 20. 5 and 9 plus 20 into Narre Warren South, so good signal from you. Thanks, Jack. And I usually miss out on the. They usually have one of the local people come in with a food truck, and they usually cook up hamburgers and whatever it is on the menu, and I usually try to get across there to have that and and a drink. But sometimes we get so carried away over in the radio astronomy area. People come over and talk to us and want to be, to see this and see that. We lose track of time, so doesn't matter. But I hope to have a little bit of a bite to eat up there. Anyway, no worries, Jack. I'll report on it the following week. I'll be able to come up and give you guys a rundown of what happened up at the Starbecue, how many people turned up, and whether the sky was cloudy and nobody saw a single star, or whether the viewing was good. That's the only problem with astronomy, isn't it? We're dependent on the weather. Okay, across to you there, Andrew, VK3KIS, VK3EKH.
VK3EKH, VK3KIS, good evening, Kent, and all in the group. I actually have a technical question when it comes to telescopes. I have a 114 millimeter telescope, refractor with a 900 mil focal length, and I was wondering if it's worth going to the 5-inch diameter with a 1 meter focal length. It's only a difference a couple of millimeters, so I don't know if it, as far as focal length is concerned, so I don't know if it's worth the effort. If you got any advice for me, I'd certainly appreciate that. Back to you.
Okay, Andrew. What exactly was the question again, though? It was a little bit mixed up. I've got the telescope as having a focal length of 900 millimeter. but I'm not too quite sure if it's the lens size, how large the aperture is at the front. How large was it?
The aperture is 114 millimeters diameter on the one that I currently have. And I was thinking of going to the 5-inch diameter, which is 130, I think it is, by 1,000.
Telling to go for it.
1 meter focal length.
Do you want to say something, Steve?
Yes, good evening, Andrew. Stephen here. I just heard that. Aperture counts for everything, you know. The bigger the better. Go for the 130 millimeter one, Andrew. Good luck with that.
Okay, thanks for that. Now just got to convince management. Okay, thanks for all that, and we'll do it again next week. VK3EKH, VK3EKIS, 3 mate.
Thanks, Steve. VK3KIS, VK3EKH. Yeah, I just got mixed up with what you were trying to ask at the beginning there, but that's why I repeated it. But when you said 130 as opposed to 114, as Steve says, the bigger the collecting area, the better that telescope's going to be for you. So yes, go for it for sure. I don't think you'll be disappointed. All right. Actually, I should. This is probably, well, not right now, but I've got a little article that that Perry Vlahos wrote many years ago for the Green Guide on what to look for when buying a telescope. It's probably due to read that one back out again. It was always very popular. Anyway, thanks, Andrew. Good on you. Across to Dallas, VK5 Whiskey Alpha, VK3 EKH.
VK5 Whiskey Alpha. Yeah, good evening, Clinton, everybody here. A little bit difficult conditions here. I've got some sort of really bad modulation, plus 80 metres. It's been a few weeks, so I've supplemented a bit of the listening with Kiwi. I've got nearby a little bit quieter. But of course, being a vertical, it doesn't pick up the sky waves quite as well, the high angle. But you're good, 10 to 20 over with the extra power, I'd say. Half the stations are almost unreasonable and the other are quite good, so quite reasonable considering the noise level. I didn't really write down the numbers here. I was shuffling between receivers trying to pull people out of the noise at times. I hope I'm being heard there, and good on the broadcast, interesting stuff, and that sounded quite okay on the Kiwi, the broadcast there on 80 metres when I got it going there, so good old Clint, we'll catch you again, VK3 Echo Kilo Hotel, VK5 Whiskey Alpha.
Thanks, Dallas. VK5 Whiskey Alpha, VK3 Echo Kilo Hotel returning. Good signal, 5 and 9 plus 10, 5 and 9 plus 10 into Narre Warren South, so quite consistent. No copy, not a bad signal coming from you there, Dallas. And thanks for the report on tonight's transmission as well, and the interference, a little bit of interference that you seem to be getting there, and copy on the Kiwi SDR. Yeah, so I've heard about that, the particular Kiwi SDR that's over there. I haven't gone looking for it yet, but apparently it's very well set up with a very good antenna system. I think it was a spider antenna, I think you referred to it as. So yeah, not a bad setup for an SDR. That's one thing that we hope to do up at our dark sky site with the radio astronomy station, is to also have an SDR running up there too, as part of the suite of equipment we've got going. When that ever happens, I'll let you guys know that there is that there will be an active SDR running up there that one can tune into to play with as well at some stage in the future. But as Steve VK3YGJQ indicated, we've got a 8.5 metre dish up there, a Kennedy dish, 1.8 metres, 1.8.5 metres, get it right, 30 foot is another term. And it's fully steerable to all points of the sky, and controlled by a computer, and we currently have a hydrogen line receiver sitting at the focal point to start doing some hydrogen line activity on Doppler and also mapping the sky. So hopefully we'll start getting some successful results from that setup. The COVID restrictions have been really causing us a lot of problems the last 18 months with not much activity occurring. So hopefully getting back up there will start the ball rolling again, and we'll start getting some results happening, which will be fantastic. Anyway, alright, I'll take one more listen, and if there's any other stations, call in. Otherwise, we'll close down for tonight. This is VK3 EKH listening on 80 metres.
VK3 EKH, VK3 BAT, just checking in, as usual.
Alright, thanks Tony. Not sure if there was another station there, a bit weak. But yep, thanks Tony, good signal from you. Yes, excellent signal in fact. Anybody else out there? Just a distant shipping yacht vessel. Alright, thanks everybody for listening tonight and watching on the YouTube stream and on the television repeater. To everybody up there on the chat window, which was just Martin, VK7JAH, and John, VK3BLX. Thanks for joining in on the chat window. And to the folks that sent emails, David, Don, Ian and Stephen, thanks guys, appreciate that. And like I say, David, VK2ELS, just send us an email on what you were saying, be good to catch up. VK3EKH at gmail.com. And more information about this broadcast and station can be found on QRZ.com. Just go to QRZ.com and enter VK3EKH and it all will be revealed. There's some further pictures of the station and the various antennas that we use and whatnot. And more information about the Astronomical Society of Victoria, of course, can be found at the website www.asv.org.au. And I think we actually have, just before I disappear, I keep forgetting to do this, when it comes to this time of the month, just a very quick check of what's happening. Let's see, where are we? Calendar. There's the calendar. The monthly meeting for ASV is coming up, and it will be, if the monthly meeting is slated for the 8th on Wednesday, and it will be an Astro Talk, ASV Astro Talk. Topic will be machine learning in astronomy. Yep, machine learning in astronomy and using it to find fast flaring stars. The speaker is Sarah Webb from the Swinburne University, and it will be streamed on YouTube. It will be streamed on YouTube and also the Facebook page. If you're if you have Facebook, go to the ASV Facebook page and you'll see the video stream as well there. So next next Wednesday, coming up Friday. Yep, next Wednesday, the 8th. In fact, we're actually looking at this. We're back at the Herbarium in Melbourne. So our first meeting, our first get-together meeting in Melbourne at the National Herbarium, the Muller Auditorium in Burwood Avenue, Melbourne. So that's next Wednesday, 8 o'clock. It starts to about 10. And we've got Sarah Webb of Swinburne University talking about machine learning in astronomy and using it to find fast flaring stars. And like I say, you can watch it on YouTube. It'll be streamed on YouTube and the Facebook page. So that's next Wednesday, 8 o'clock. Is our Saturday, is our December ASV meeting. I'm not sure if I'll be able to. I think there's probably a ticket event too. I think they're after ticket and double vaccination things and all that sort of stuff. So best to look at it on YouTube, I'd say. Anyway, on that note, we're out of here. Thanks for watching and listening. This is VK3 Echo Kilo Hotel concluding transmissions on 3541 kilohertz for tonight. and we'll be back next Friday. Cheers, everyone. Take care. And everybody on the YouTube stream, take care, look after yourselves, and we'll be back next Friday to do it all again on YouTube. So we just shall close the YouTube stream down, and there'll be, of course, the broadcast this Sunday morning, the WIA broadcast on Sunday morning at 10:30. I forgot to mention that, and that's it. Oh, followed by the Old Timers Club too. The Old Timers broadcast will also be following the ASV broadcast. So that's the Sunday morning, 10:30. Be there or be around. Closing the stream down. Stop stream, yes. Cheers everyone watching the stream.